Alright, so as promised, here's an update on my AC zone control project. In the last video, showed that the room module was done. This is the attic module with the servo that is to open the dampener valve. There is a very crude interface. Right now it's just a functional thing, haven't begun styling it. So again, what we're working with here is basically the master bedroom room module, and then this will eventually have many more servos attached to it, but for this demonstration, this is just the servo that would be connected to the valve that controls the airflow to the master bedroom. So right now the temp sensor is reading 73 degrees. And if we go over here, you can see that there is a input field to change the desired temperature for that room, and then this is just the Thingspeak iframes inlaid. Eventually this will just be the actual numbers and everything will be styled. But here we have the actual room temperature that's averaged out. This is the desired temperature for that room. This is the valve status, whether it's calling for it to be open or closed. And this is just for calibration purposes. It won't be there in the long run. This is to calibrate the thermistor. Every thermistor is going to be a little bit different, so this allows me to change it via the web without having to tweak any code on the ESP8266 or physically adjusting a pull-up resistor or something like that, or potentiometer or something like that. So what I'm going to do is demonstrate that also the built-in LED for this will change to blue whenever the valve is it's sending a signal to Thingspeak to open the valve. So there's quite a few Thingspeak channels that I'm actually using. So this is reading data from a Thingspeak channel to get calibration data, and there's one field for every room. I have 7 rooms. Then there is also a Thingspeak channel devoted to the desired temperature. Again, one field per room. And then there's 2 different Thingspeak channels that it's going to write data to. One is going to be the valve status. So each individual room module is going to write a 0 or a 1 to the field for that room to open the valve or close the valve, and that's what this one is reading. It's simply reading that one channel, all 7 fields. If the field is a 1, move that servo. If it's a 0, move it to the closed position. So there's also another channel that is just detailed information, and that's going to contain the raw sensor output, the average temperature, the humidity, and a couple other things. So first thing I'm going to do is just warm up this thermistor, and we're going to see the temperature raise. This is only updating about once every 20 seconds, so it's going to take a little bit of time. But right now the desired temperature is set to 75, I believe. So once the temperature gets above 75, you're going to see the blue LED come on. There it is. And then we're going to see the servo move. And that would basically be, there it is. So the valve has opened. This is allowing, in the summertime, more air condition into the room, assuming that the air conditioner is running. And then once this gets below 73, I think, or 74, it's going to send the signal to close the valve. And it's not going to actually close the valve all the way. It's only going to close the valve to, it's going to close it by about 60 or 70%. Alright, so now the temperature is starting to fall. I might kind of help it out here with a cold can. we go. So the light goes off, and then that's going to send the signal for it to close. It looks like the ESP8266 read that before the web client here updated, but we'll see that. There we go. So it drops down to a 0. This module reads that particular channel and field, and then commands the servo to move to the closed position. Thanks to the help of some people in the Arduino forum, it only sends that right signal for about a second, and then it stops sending the signal. Otherwise, these digital servos have a tendency to kind of hunt back and forth or jitter, and that can cause excessive current draw. And even though this is a coreless motor in the servo, there's no brushes, it still will cause premature wear. So it takes quite a bit of force to move these idly, but they can be moved manually, but it does take a lot of force. More than that valve is going to be acting on it. So it only sends that signal if the value is changed. Otherwise, the servo just sits there in an idle state. If I wanted to manually adjust that temperature in the room, I can do that. So right now the current temperature is 73, and the desired temperature is set at 75. So right now the room is colder than the desired temperature, therefore the valve is in the closed position. Let's say I wanted to drop the temperature in this room, assuming that the main AC is running. I'm going to send a commanded temperature of, let's just say 70, well 72. Yeah, I think there we go. And still haven't fixed that. I don't want it to go to another page. So now the desired temperature is going to be set to 70, which means that the there we go, turn blue, and the valve opened, and there's the status set to a 1. So it's manually controllable, and it also works automatic. Now I do have a Wi-Fi enabled thermostat, and it does run on a 7-day schedule. So one of the questions that was asked was, well, what happens if you set the temperature to a higher temperature during the day while you're at work? Well, let's say that each room has a desired temperature of 72. The Wi-Fi thermostat is going to be set to 75 while we're away at work, which means that every room's valve is going to open because it's hotter than the desired temperature. Every valve is going to be in the open position. That means when the schedule on the thermostat comes back to say, okay, let's start cooling down the house, every room is going to get 100% airflow, which is the way it probably should be. As individual rooms start to cool off faster than the others, the valve will close. So let's say that the guest bedroom, which is a smaller bedroom, closes or cools down quicker than the living room, the kitchen, and the master bedroom. Well, the guest bedroom is going to read that temperature. It's going to get down to 72, 71, whatever I have it set to, and then it's going to command that valve to close, only allowing a small amount of airflow into that room, forcing more air into the other rooms, which is going to cool the house down faster. That was the whole point of this project. And thanks to the help of a lot of people online on the Arduino forums, as well as just a lot of time playing around, this is what I've got. It's exactly what I want. Now I just need to physically rig the servo up to the air duct, and I'll do a video on that. And then of course make this interface a lot prettier and user-friendly. But it is functional. It's functional without any manual input. As long as I set the desired temperatures per room, and then if I really want to, I can make this interface a lot nicer. But the way it is now, it's usable, you know. So that's my project. Thanks.